Okay, so our next step in our VFR cross-country planning is to choose our cruising altitude. In terms of our cruising altitude, there's a few things that will narrow down our selection. Probably one of the first things to look at is the terrain and obstacles along the route of flight. So if you're operating in mountainous terrain, then obviously you'd want to choose a higher altitude to avoid that terrain and those obstacles. For our particular flight from Brainerd to Grand Forks, that's not much of a concern for us. So pretty much anything above 1,500 is probably going to be just fine in terms of obstacle and terrain clearance. Beyond that, things like the weather, so the ceiling may restrict your choice in altitude. So if you have a low ceiling, then obviously you're going to have to stay slightly lower to remain VFR. Things like turbulence may also be a consideration. If there's an air met for turbulence, it will list the altitudes that will apply to, so that may restrict your selection a little bit. And then finally, another thing to look at is performance. So the higher the altitude, the greater your true airspeed will be. For our particular aircraft, a piston-powered single-engine airplane, we can't really go that high, so the difference in true airspeed is not going to be that great between the altitudes that we're going to fly at. Also, something to consider is the length of the flight. If it's a very long flight, generally you would want a higher altitude. It's going to be more likely to have a more comfortable ride at the higher altitude you are. And also, if you have a problem in flight, the higher you are, the more options you have in terms of nearest airports that you can get to. For a very short flight, then you would generally want a lower altitude. That way it'll reduce the workload. Otherwise, if you have a high altitude, you're going to be climbing and then followed by an immediate descent, which would be a very busy flight. So those are some things to consider. For our particular flight from Brainerd to Grand Forks, I think realistically we only have a few options. We are a westbound flight, and we're VFR, so a westbound VFR flight must be cruising at an even altitude plus 500 if you're above 3,000. If we're heading eastbound, then you would choose an odd altitude plus 500. Realistically, I would say that our altitudes that we can choose from are probably 4,500 and maybe 6,500. 8,500, that I would perhaps avoid that unless it was a really long flight, just because it's going to take you a while to climb to that altitude. You're going to use a lot of fuel to get there as well. So 4,500, 6,500, lower than 4,500, so you'd perhaps be looking at 2,500. I would say is maybe perhaps a little bit too low. Again, it's unlikely you're going to have any problems with obstacles or terrain, but it's certainly going to limit your options if something went wrong in the airplane and you're looking for a place to land. 2,500 is going to be a bit low. So 4,500 and 6,500 are probably our best choices for today. So now I'm going to take a look at the winds aloft to determine which altitude would give me the best true airspeed. Obviously a tailwind will get us there a little faster versus a headwind. So the winds aloft for today in Grand Forks, there is also a forecast in Alexandria, but I think we're going to be a little too far away for those winds to apply. So we're going to look at Grand Forks instead, and we have a winds aloft forecast at 3,000 feet. We have a forecast at 6,000 feet, and we have a forecast at 9,000 feet, and then beyond that as well. So at 3,000 feet, the winds aloft are 12011, 6,000 feet, 28015, with a temperature of -2, and at 9,000 feet, 27023, with a temperature of -7. So for our flight, we're heading westbound. So I would say anything above 6,000 is probably going to be a poor choice in terms of our ground speed, because we're going to have a headwind that we're going to be encountering, a wind out of the west. Whereas if we stay below 6,000, it looks like we're perhaps going to have maybe a slight tailwind. with a wind generally out of an easterly direction, or even a southeasterly direction, which is the direction which we're coming from. So I would say 6,500 is probably out of the question now in terms of our ground speed. 4,500 looks to be the best option. So 4,500 is going to be right in the middle of these two values here. It's 1,500 feet greater than 3,000, 1,500 feet less than 6,000. So to figure out the wind at those altitudes, we can interpolate. We can take the difference between these two values. So 280 minus 120, that leaves us with 160. If we divide that by 2, that gives us 80. We could add that 80 to 120, our lowest value up here, and that would give us a wind direction of 200 at 4,500 feet. Same thing with our velocity, 11 knots and 15. So if we do 15 minus 11, that would be 4, and we would divide it by 2 since it is exactly halfway between our two forecasts here, and that would obviously be 2. So our winds, if we add that 2 to our lowest value, the winds aloft at 4,500 would be 200 at 13. As far as temperature goes, we've got a temperature at 6,000. We do not have a temperature at 3,000 because it's not reported, because this altitude is within 2,500 feet AGL of the surface in Grand Forks. So they do not report a temperature at those altitudes. But if we assume a standard lapse rate, which is a decrease of 2 degrees Celsius for every increase of 1,000 feet, so in this case, from 6,000 to 5,000, we would see an increase in this temperature by 1 degree. So this would be minus 1 degrees at 5,000, or excuse me, 0 degrees. So that's 1,000 feet, right? For every 1,000 feet, a 2 degree change in temperature. So that'd be 0 degrees at 5,000 feet. So at 4,500, that would be minus 1 degrees, because that is 500 feet away from that 5,000 feet. So 4,500 to summarize, wind is 200 at 13, and the temperature is minus 1 degrees Celsius. So we've got that winds aloft figured out. We can go ahead and place that in our navigation log. 200 at 13 minus 1 degree. Now since we're using the same winds aloft forecast for the entire route of flight, we'll put the same values in each row. We can also go ahead and put our altitude in there since we settled on 4,500. So we'll put that. We don't intend to change our altitude along this route of flight, with the exception, of course, of the climb and descent. We'll talk about that later. Okay, so we got our altitude in there, we got our winds aloft in there. We can also go ahead and determine things like our true airspeed based on the altitude that we've now selected. We'll get that from the POH. And then we can also use the E6B to determine our true heading, and therefore our magnetic heading. And we can use it to determine our ground speed as well once we have our true airspeed figured out.